Hello, you're welcome to my Simple Maths YouTube channel. Please don't be a stranger on this channel. If you're yet to subscribe, please do so. And don't forget to click on the notification button. That way you'll be notified when we have a new video. And please like our videos and share. Okay, so today in our class we'll be looking at algebra questions. Now take note that these questions require critical thinking. The aim is to look at questions that can help us to reason properly, especially for children in upper primary. So let's get to business. Question 1 says, calculate 25 times 12. I know a lot of you are used to the long way of calculating, or the long multiplication method, but I want to teach you a short method of multiplying. So since we have 10 and 2 to make 12, I'll just say 25 times 10. This is easy, isn't it? I'm just going to add 0 to my 25 to give me 250. And then I'll say 25 times 2. This is also easy. 25 times 2 is 50. And then I had 250 and 50 together to give me 300. You can see that this is quite faster than your long multiplication method. So my answer is 300. My answer is 300. Alright. Let's go to the next question. Question 2. You have to calculate 311 minus 111. Okay. So another way I can do this is to start by subtracting 11 from 311. So if I subtract 11 from 311, that will give me 300. And then I subtract 100 from 300. This will give me 200. So my answer is 200. So this method is a way of helping us. If you are solving objective questions, if you're able to use short method like this, it makes it easier. You don't waste unnecessary time solving your question. Is that taken? Correct. Alright, question 3 says, which of the following is not a prime number? I hope you still remember a prime number. A prime number is a number that can be divided by 1 and itself only. So our prime numbers are actually 1, 2, 3, 5, 7. Is that taken? Alright. So which of the following is not a prime number? Okay, we'll look at this. 13 is a prime number. 5 is a prime number, isn't it? 19 is a prime number. 7 is a prime number. But 8 is not a prime number. Why? It is not a prime number because it is divisible by 1, 2, 4, and 8. So you can see it's actually divisible by 4 numbers and not only 1 and itself. So 8 is not a prime number. Do you understand this? Correct. Question 4 says, what is 215 centimeter in meters? It simply means change 215 centimeter to meters. Now when you're changing from centimeter to meters, you divide by 100. But if I'm changing from meter to centimeter, I multiply by 100. You remember that? Good. So to change this to meter, I'll just say 215 centimeter divided by 100. Okay, so you still remember how to do this. Okay, let me remind you. I'm dividing by 100, so I'm moving 2 places to the left. 2 places to the left. I just move this way. 1, 2, and this gives me 2.15 meters. So I have changed 215 centimeter to meter. Simple, isn't it? Good. Question 5. This is a fraction, isn't it? Evaluate 11 over 22 plus 22 over 44 minus 33 over 66. So the first thing I want to do is to reduce this into its lowest thing. All these are big numbers that can be reduced. I can say 11 here 1, 11 here 2, and that will give me 1 over 2. I can say 22 here 1, 22 here 2, and this is another 1 over 2. And then I can say 33 here 1, 33 here 2. That is 1 over 2. So now I have 1 over 2 plus 1 over 2 minus 1 over 2. 1 over 2 plus 1 over 2, that is 1. And then 1 minus 1 over 2 is 1 over 2. So my answer is 1 over 2, also known as half. Do you understand? Good. Question 6. Find 15% of 200. 15% of 200. Percentage is actually in 100. So 15% means 15 over 100. So that would be 15 over 100 times 200. So I can say 100 here 1, 100 here 2. And then 15 times 2 is 30. So my answer is 30%. Is that taken? Correct. Question 7 says, evaluate 5 times 6 minus 3 times 4 divided by 2 times 3 minus 1 times 3. Now when you have questions like this, you need to use your board math. Some people call it PEMDAS. Whichever way, it's still the same thing. So in board math, it simply means my bracket comes first, then my off, division, multiplication, addition, and subtraction. So since my multiplication comes before my subtraction, I would have to do the multiplication first. So 5 times 6 is 30. 3 times 4 is 12. So that gives me 30 minus 12 divided by 2 times 3 is 6. 1 times 3 is 3. So this gives me 6 minus 3. Is that taken? Alright, so 30 minus 12 is 18. 6 minus 3 is 3. Then 18 divided by 3 will give me 6. So my answer is 6. Are you okay with this? Good. Question 8 says, find the highest common factor of 120 and 210, also known as the HCF. Now in HCF, what are we trying to do? Looking at numbers that can divide both numbers without a remainder. Is that okay? So I'm going to start with the lowest number possible. I'll start with 2. If I say 120 divided by 2, that will give me 60. 210 divided by 2 will give me 105. Okay? I can divide 60 by 2, but I can't divide 105 by 2. So I'll move to the next number, which is 3. 3 in 60 is 20. 3 in 105 is 35. If you get that, I just say 3 here, 3. I'm left with 1, 3 in 15, 5. So that's how I came down my 35. Now look at 20 and 35. 2 cannot divide both number. 3 cannot divide both number. But 5 can divide both number. So I'll divide by 5. 20 divided by 5 will give me 4. 35 divided by 5 will give me 7. Now I'm left with 4 and 7. No number can divide 4 and 7 without remainder. That means I'm going to stop here. I can't divide further. So I bring out all these factors. Those are going to be my highest common factors. 2 times 3 times 5. That will give me my HCF. 2 times 3 is 6. 6 times 5 is 30. So my highest common factor is 30. Is that taken? Good. Alright, question 9 says, express 24 as a product of prime numbers. This is similar to finding the HCF. So I'm just going to start dividing by the smallest number possible until I get to 1. So 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. So I'm going to stop here because I've gotten to 1. Is that okay? Alright, so expressing number as prime, as product of its prime number is just like, when you want to do your LCM, the way you keep dividing until you get to 1, that's what we do with products of prime numbers. So after getting that, I'm just going to write out all the factors. That is 2 times 2 times 2 times 3. How do I check that I'm correct? I have to multiply all of these factors together and it has to give me the original number. So let's check. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So this is correct. We have been able to express 24 as a product of its prime numbers. Do you understand this? Good. Question 10 says, what is the missing number in the box? What is the missing number in the box? You are asked that 150 divided by unknown is equals to 10. That means what number would I divide by 150 to give me 10? Simple. I'll just say 150 divided by 10. And 150 divided by 10 is 15. So that means 150 divided by 15 will give me 10. Or better still, I can say, okay, what number would I multiply by 10 to give me 150? 15 multiplied by 10 will give me 150. So 15 is the missing number. Is that taken? Correct. Okay, question 11. If numbers A and B are odd numbers, you still know what odd numbers are, isn't it? Okay, then which of the following is even? So if A and B are odd numbers, which of the following? You have some numbers here, you have to determine which of them would be even if A and B are odd numbers. So now, since we said odd numbers, we didn't mention any particular odd numbers. That means we can pick any odd number. So make the work easier. Let's just pick two odd numbers. You can pick 7, you can pick 5, whatever. But I'm going to use 1 and 3 as my odd numbers. I'm going to represent A and B as 1 and 3, just for us to check which of these expressions is going to be even. Okay, so I'm going to assume my A to be 1 and my B to be 3. What that means is I'm going to substitute 1 and 3 into each of this expression and see which of them will give me an even number. So I'll start with 3A plus 2B. So if I'm using this, I'm assuming my A to be 1 and my B to be 3. So if A is 1, 3 times 1 will give me 3. And then if my B is 3, 2 times 3 will give me 6. 3 plus 6 is 9. So this expression is odd. It's not an even number. And I'll go to the next one. A times B plus 5. If my A is 1 and my B is 3, that means 1 times 3 will give me 3 plus 5. 3 plus 5 is 8, isn't it? 8 is an even number. So that means this expression is even. And then I'll move to the next one. A times B, that is 1 times 3. 1 times 3 is 3. That is odd. So this is odd number. Then I'll move to the next one. A plus B plus 1. A is 1, isn't it? B is 3. 1 plus 3 plus 1. 1 plus 3 is 4. 4 plus 1 is 5. 5 is also an odd number. Is that taken? Then I'll go to the next expression. A times B. That is 1 times 1 times 3. 1 times 1 is 1. 1 times 3 is 3. This is also an odd number. So if you look at all of this, this is the only even number we have there. 8. And that is A times B plus 5. So A times B plus 5 is even. Is that taken? Remember, I'm the one using 1 and 3. You can use any odd number. If I had used 5 and 7, 11 and 13, I would have still gotten the same answer. This is just a way of helping us confirm whether this expression is even or odd. So we could have used any of the odd. Okay, so that's how it works. You get that. So like I was saying, you can use any odd number. Take note, if I've used any odd number, I might not get all the same answer, but whatever answer I get will still be odd for this, even for this, odd for this, like that, just to show to us whether the expression is odd or even. Is that taken? Alright, so question 12. Which of the following is not a factor of 80 but multiple of 8? So factors are numbers that can divide a number without a remainder, while multiples are numbers that you can use a factor to divide them without a remainder. Do you understand? So like if I said 80 now, factors of 80 will be like 2, 4, 8, 10, like that. And then multiples of 8 will be 16, 60, 64, like that. Numbers that can actually divide 8 without remainder. Do you understand that? Alright, so we have some numbers here. We are asked to determine which one is not a factor of 80 but is a multiple of 8. Alright, so we have 40, 20, 48, 25, and 5. 40 and 20 are factors of 80. Yes, we know that, isn't it? Then 25 and 5 are not multiple of 8. Did you get that? But then 48 is not a factor of 80, but it is a multiple of 8. Because 48 can divide 8 without remainder, so it is a multiple of 8, but it is not a factor of 80. So 48 is the answer. Shall I take that again? 40 and 20, they are factors of 80. 25 and 5, they are not multiples of 8, but 48 is a multiple of 8, but not a factor of 80. Is that taken? Good. Alright, question 13 says, find the value of x. Find the value of x in this expression. 5 over 3 is equals to x over 15. So there are different ways I can do this. I can either cross multiply and say 3 times x, 3x is equals to 15 times 5. But a shorter way of doing this, I'll just look at the what number would I multiply by 3 to give me 15? 5, isn't it? 5 times 3 will give me 15. So the same number that I'm multiplying by 3 to give me 15, I'll multiply it by 5. So if 3 times 5 will give me 15, then I'll just say 5 times 5 will give me 25. So my x is 25. Do we understand that? Good. Alright, question 14 says, if 3 over 4 of a number is 9, then what is the quarter of the number? You still know what quarter means. Quarter is 1 over 4. Let the number be y. We have to give the number a particular alphabet because we don't know what it is. It's unknown. So let the number be y. 3 over 4 of y. Up means multiplication. So 3 over 4 times y is equals to 9. 3 times y is 3y. So we have 3y over 4 is equals to 9. Then of course multiply by saying 3y multiplied by, there's a 1 here, and 4 multiplied by 9. So 3y is equals to 9 times 4. 9 times 4 is 36. 3y is equals to 36. And then I divide both sides by 3. 3y divided by 3 will give me y. 36 divided by 3 will give me 12. But take note, I'm not just asked to look for y. I'm asked to find the quarter of the number. The number is 12. So if the number is 12, I'll look for quarter of 12. And quarter of 12 is 1 over 4 times 12. 4 here 1, 4 here 3. 3 times 1 is 3. So that is the quarter of the number. The quarter of the number is 3. Is that taken? Good. Question 15. 8 apples cost 320 naira. How much will 10 apples cost? If 8 apples cost 320 naira, how much will 10 apples cost? Alright, so if 8 apples cost 320, then for me to know the cost of 1 apple, I'll just say 320 divided by 8. And that will give me 40 naira. So 1 apple costs 40 naira. If 1 apple costs 40 naira, then 10 apples will cost 10 times 40 naira. 10 times 40 naira. And 10 times 40 is 400. So 10 apple costs 400 naira. Do you understand that? Very good. Question 16. The amount of sugar in 5 different foods was measured as a percent. The data is summarized in the bar graph below. Which of the foods has the highest concentration of ingredients not including sugar? So take note of this. The highest concentration of ingredients not including sugar. What it simply means is which of them has the lowest sugar content. Which of them has the lowest sugar content? That's just the meaning. So this is the graph. You have crackers, chocolate cake, ice cream, peanut butter, and ketchup. So I'm going to, in the next slide, I'm going to show you what numbers each of these graphs reads. Is that taken? So this is it. Ketchup has 8.8%, peanut has 9.2%, ice cream has 21.4%, chocolate cake has 30.3%, 11.8% for crackers. Now if you look at all of this, this is the lowest. Ketchup has the lowest percentage of sugar, so that is going to be the answer, is the one that has the lowest amount of sugar. But physically speaking, even looking at all of these, you all agree with me that all of these ones, crackers, chocolate, they have high quantity of sugar, except for ketchup. Ketchup is that tomato paste that they use for cooking. So this is the one that has the lowest percentage of sugar, and that would be the answer. Is that okay? Question 17. Which of the following is false? Which of the following is false? Now this is 7 whole number 1 over 3 is equals to 7 plus 1 over 3. This is correct. This is actually true. And then you have 15 over 37 is greater than 15 over 33. This is false. This is false because this is actually greater than this. And C, 5 whole number 2 over 3 is greater than 5 whole number 1 over 3. This is true. 5 over 2 is equals to 2 whole number 1 over 2. This is true because I'll just say 2 times 2, 4 plus 1, 5 over 2. This is true. 4 plus 3 is equals to 3 plus 4. That's true. 4 plus 3 is 7. 3 plus 4 is 7. So they are all true except for B. 15 over 37 is greater than 15 over 33. This is not true. Is that taken? Good. Question 18. How much grams of rice should we add to 1.35 kilograms of rice to get 2.5 kilograms of rice? How much gram of rice? I don't know. So let me call it X. How much gram of rice should I add? So if I say X plus 1.35 kilogram will give me 2.5 kilograms. So to get the value of X, I'll just say 2.5 kilogram minus 1.35 kilogram. As if we are collecting like times. 1.35 comes here, and then X will be left here. So 2.5 kilogram minus 1.35 kilogram will give me 1.15 kilogram. You might want to pause the video so that you can do your calculation. No problem. And if you are confused of anything, you can always pause to check and then rewind to listen again. Alright, so 2.5 kilogram minus 1.35 kilogram will give me 1.15 kilogram. But remember the question says how many grams? That means I have to change 1.15 kilogram to gram. And how do I change kilogram to gram? I'll multiply by 1000. So 1.15 multiplied by 1000. Okay, 1000 has 3 zeros. So I'm going to move my decimal points 3 places to the right. 1, 2, 3. That means I'll add another 0, and that is 1150 grams. So this is the amount of gram that I would need to add to 1.35 kilograms to give me 2.5 kilograms of rice. Is that taken? Good. Question 19 says, if the sum of n natural numbers can be found with the following formula: 1 plus 2 plus 3 plus dash 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 plus n is equals to n into bracket n plus 1 over 2. So this is actually the formula for finding the sum of natural number. And then you are given the natural numbers to be 1 plus 2, 3. That means you continue counting till you get to 21. So what this means is that the number of natural number we have is 21. N is 21. All I need to do is to put this value of n into my formula. So my formula is n into bracket n plus 1 divided by 2. Anywhere I see n, I'm going to be putting 21. 21 into bracket 21 plus 1, bracket close, divided by 2. 21 plus 1 is 22. 21 times 22 divided by 2. 21 times 22 is 462. And then I divide this by 2. 2 in 4, 2. 2 in 6, 3. 2 in 2, 1. So my answer is 231. This is the sum of natural numbers. Is that taken? Very good. Question 30. How many whole numbers are there between 2.09 and 15.3? You know your whole number, numbers without decimal. So after 2.09, the next whole number is 3. So I'm going to count 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Remember, between 2.09 and 15.3. So the last whole number is 15. So let's count. How many whole numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 whole numbers between 2.09 and 15.3. Is that okay? Very good. Question 21 says, Bello likes to add numbers, digits, that shows the real time on his electronic clock. You know an electronic clock, isn't it? Your digital clock, not the manual one. Those digital clock that shows 2.00, 1.59 like that. That's your electronic clock. Just like you have it on your mobile phone or on your computer screen. So the question is asking, what is the highest amount it can get? So the lowest number you can have on your electronic clock is actually 00.00, and the highest number you can have there is 23.59. So this is the highest number. All I just need to do is add all the digits of these numbers. Do you get that? So 2 plus 3 is what? 5. 5 plus 5 is 10, and 10 plus 9 is 19. Is that taken? Very good. Question 22. What is the sum of the values of A and B if 5-digit numbers 428 AB is divisible by 2, 3, and 5? Okay, so what this question is telling us that is that 428 AB. This is a 5-digit number that can be divisible by 2, 3, and 5. So for us to solve this question, you have to remember your divisible law for 2, 3, and 5. And what did that law say? It says for a number to be divisible by 2, the digits in the unit place, this is the unit place, has to be even or 0. For a number to be divisible by 3, the sum of all the digits has to be divisible by 3. That means by the time I had 1, 2, 3, 4, 5 digits together, the sum must be divisible by 3 if this number has to be divisible by 3. Then for a number to be divisible by 5, it has to end with 5 or 0. That means this B has to be 5 or 0 if this number must be divisible by 5. Now, having this at the back of our mind, the next thing we're going to do is to see how we can get A and B. So I'm going to start with B. Already I know that for B, so for this number to be divisible, B has to be either 5 or 0. So if I'm saying my B is 5, that means that number cannot be divisible by 2, because we have said the unit place has to be even if it must be divisible by 2. So that means this cannot end with 5, it has to end with 0. So that way we have been able to get B. B is 0. So the next thing is to get the value of A. So what I did is to try to eliminate. We start by putting this as 1, then you check if it's divisible by 2, 3, and 5. You put 2, check if it's divisible by 2, check, you put 3, like that till you check for all the numbers. So after doing that, these are the 3 numbers that are divisible by 2, 3, and 5. You have 42810, 42840, 42870. These 3 numbers are divisible by 2, 3, and 5. So how do I know which of them I'm going to pick? Look at your options here. You have 8, 10, 12, 13, and 1. So the next thing is to add, because they actually asked what is the sum of the values of A and B. So if I'm saying this is the number, 1 plus 0 is 1, isn't it? And I have 1 here. But if I look at this, 4 plus 0 is 4. I don't have 4 in the option. 7 plus 0 is 7. I don't have 7 in the option. So that means E, 1, is the answer. And that means this is the 5-digit number. Do we get that? 1 plus 0 is 1. 4 plus 0 is 4. 7 plus 0 is 7. So what we are trying to say now is that my A is 1 and my B is 0. And then the 5-digit number is 42810. But actually the answer, the question we actually have is to find the sum of A and B. So if I've concluded that 42810 is my 5-digit number, I just sum A and B. 1 plus 0, 1. And that makes 1 the answer. Is that okay? Good. Question 23. The person was asked, how old is he? He replied, if I add up my age now, and 1/2, quarter, and 1/3 of my age now, then I'll be 100 years old. How old is the man? Okay, so we don't know the man's age. Let's just look for a number, a letter to represent his age. So I'm going to use W. Let the man's age be W. Okay, so if I add up my age, his age is W, that's W. 1/2 of my age, that's 1/2 of W. Quarter of my age, that's 1/4 of W. 1/3 of my age, that's 1/3 of W. If I add all of this together, it will be 100. Is that taken? So 1/2 W is same thing as saying W over 2. 1/4 W is same thing as saying W over 4. 1/3 W is same thing as saying W over 3. So I'll add all of this together to give me 100. So I would have to find the LCM of 1, 2, 4, and 3. And the LCM of these numbers is 12. Alright, 1 in 12 will give me 1. 1 times W, 12W. 2 in 12 will give me 6. 6 times W. Let me take that again. 1 in 12 is 12, so 12 times W, 12W. 2 in 12 is 6. 6 times W, 6W. 4 in 12 is 3. 3 times W, 3W. 3 in 12 is 4. 4 times W, 4W is equals to 100. Okay, so I'm going to add all of this together. 12 plus 6 is 18. 18 plus 3 is 21. 21 plus 4 is 25. So 25W. And then I cross multiply. 100 times 12 will give me 1,200. So to get W, I'll say 25W divided by 25. 1,200 divided by 25. So W is 1,200 divided by 25. Okay, I want to simplify it further by dividing both by 5. So 1,200 divided by 5 will give me 240. 25 divided by 5 will give me 5. And then I can now say 240 divided by 5. 5 and 24 is 4. I'll be left with 4. Add this 0 to it to give me 40. 5 and 40 is 8. 48. So he is 48 years old. Is that taken? To confirm, all you just need to do is to put 48 in all of this W, and you see that you still get 100. Is that okay? Good. Okay, question 24 says evaluate 1 plus 1 over 10 plus 2 over 10 plus 3 over 1,000 plus 4 over 10,000. Is that taken? So I just need to change all of this to fraction. 1 plus 1 over 10 plus 2 over 100 plus 3 over 1,000 plus 4 over 10,000. Is that okay? Alright, so I'll change all of this to decimal. Okay, so 1 over 10 is the same thing as 0.1. 2 over 100 is the same thing as 0.02. If you are wondering how I did that, remember, if I'm dividing by 100, I'll just move these 2 places to the left. 1, 2, and that will give me 0.02. Okay, this will give me 0.003. This will give me 0.0004. So for me to add, I just need to ensure that I'm arranging properly. This is the same thing as saying 1.0000 whatever. 0.1. Now make sure all your decimals are aligned. So this is 0.1, 0.02, 0.003, 0.0004, and then I can add 4, 3, 2, 1, 1. That gives me 1.1234. So this is the addition of all of those numbers. Is that okay? Very good. Okay, question 25 says Bobby left school at 2:15 p.m. He walked to the library to work on his homework. It took 15 minutes to walk to the library. Bobby's father picked him up at the library 1 hour after he arrived. Because of traffic, it took them to arrive home 45 minutes. What time did Bobby arrive at home? So let's calculate all the time that he spent, all the minutes spent, and then we add it to the time he left school. So let's start. We have 15 minutes here, 15 minutes, and then you have 1 hour. 1 hour is 60 minutes, 60 minutes, and then you have another 45 minutes here, 45 minutes. I'm going to add all of this together. 60 plus 15, that's 75. 75 plus 45, that's 120 minutes. So I'm going to change this to hour. I'll divide it by 60 because 60 minutes makes 1 hour. So 120 divided by 60 will give me 2 hours. So that is the total number of time spent. So I'll just add 2 hours to 2:15, and that will give me 4:15 p.m. Is that taken? So this is the time Bobby arrived home. Okay, do we understand this? Beautiful. Alright, now we've come to the end of the series. Watch out for the next series. But please don't forget to subscribe to our YouTube channel. Remember to press the notification button. And not just that, like and share our video. Is that okay? Alright, see you in the next class. Bye-bye.